Hello and welcome to another video. Today we have an Strix B450A Gaming Wi-Fi on our bench that came from a viewer. This guy is called Russell, he's from Australia, and he sent me this board because it has a no start. And I can already see some damage that looks like it has liquid damage actually. So have a look at that VRM face right there. And if you can see those few capacitors right there look like they're corroded. So I had it on AM5 multiple times that I had blown out drivers so that these DR MOSes at the top are high side, low side MOSFET and the driver in one package. And I had these fail multiple times on AM5 already. So this could very well explain why this is a no power. So we will have to start with checking for resistances. So let's go over to the 24 pin. Let's get a good ground with our black probe. Let's see, bottom left, 3.3 volts. That is already very low in 3.3 volts. 90 ohms might be fine though. I've seen like around 100 ohms be fine. Let's see, this is 12 volts, kilo ohms and rising, 5 volts. 1.6 kilo ohms, okay, I would expect higher than that as well. And 5 VSB seems to have very high resistance. Okay, then let's check for some random inductors. This one for the memory has 1.2, has a kilo ohms rising. Let's see for the 24 pin then directly. Oh yeah, and this has a very low resistance, but it's climbing. Is it just very big capacitance? Yeah, it was probably just very big capacitance. Okay, so this is not shorted. Okay, let's then check the 12 volts into the CPU phases. Do we have a short? That kind of looks like it. Yeah, we have a 12 volt short into the CPU phases. So whatever CPU you would plug into this could be killed by this. So how you check that? You take the notch that you see on the 12 pin connector, and then the closer pin to them is 12 volts. And then you check the inductors. In this case, we are lucky we can check the inductors on this side. And that means we have a straight connection from 12 volts to the CPU phase. I've had exactly this happen before as well. And it was one of these drivers being blown open. And I would expect that it's probably this driver then. So let's have a good look under the microscope for this driver. So right there. Yeah. Pretty sure this will be our culprit without seeing too much. Because this is just, yeah. We probably won't have to inject voltage to get that. To see that this is the one. And what is so important is to not plug this in at the first time. Because if you plug this in, this thing could get welded to the board. And then you have a very bad time fixing this. But like it is, probably just taking it off, cleaning up might resolve the short already. We definitely have to replace everything there. But that can be already... we can already solve the problem probably with that. So... because of experience with these boards, with these phases, I know I need to put this on a preheater. Because if I don't put this on a preheater, these won't remove very well. So, and in order to put that into a preheater, I want to remove these caps. We have these are all the same, all of these caps, when we have a good look at their marking. These caps are all 270 microfarads at 16 volts. And all with the polarity with the black stripe to the top. So we will remove those. I will get a preheater out. And we will have to remove that. And probably clean out the other phases a little bit as well. But yeah, I'm pretty sure this will already resolve our short circuit. So let me get a preheater out, preheat this. And yeah, before that, remove the capacitors that are on here. And then see from there. So let's see. if I can remove this now. So let's see and blast this off. We will need a lot of heat. My hot air station is turned to 475 degrees at 100% airflow. And we will also have to remove all of these components around it as well, because they are corroded, and we want to make sure that the board stays fixed. So we will be removing all of the passive components around it as well. And there it's off. That's very good to see. And let's now remove all of these up here as well. So just like that, it is cleaned off. All of the components are removed. I think the capacitor on the right will be fine to leave on there, because the main damage is at the top. As you can see, there was even like one of the traces being completely eaten, or one of the tracks here. Let's clean this up. Let's get IPA and my cleaning sponges in here. How did I miss that? There's another resistor there. How did I not notice that? That resistor was completely covered in rust, and I didn't even see it anymore that it was there. Interesting. Okay, this part here is so corroded that I will have to scrape it, even though I don't like to scrape with my tweezers or anything. But yeah, this has to be... Okay, so to assess this situation, this pad pretty sure is fine, that is connected to there. We will have to take that off that resistor still. That pad is definitely broken, so there's no connection anymore to whatever this was. And also this pad right here that is bent back like this is also not there anymore where it should be. So this is probably a power pad. This is probably like 5 volts or something like that. And these are probably signals then. And yeah, this one is salvageable. This one is not a problem. This one has to be reattached to there, because it's corroded through here. And this one has to be rebuilt here. And this has to be isolated before that. So yeah, this is definitely salvageable. Because the very good thing is it didn't burn through. So there wasn't any power given into this where it could have welded it on. But it was first brought to me where I didn't power it on, and I was able to actually assess the situation and see what was happening. So let's quickly remove that that resistor also, so that we completely have a rebuild phase there. Or like a complete clean phase, because that resistor is just way too far gone. Yeah, I cannot even properly solder to it because it's that far gone. But that is to be expected. So there it is off now. And now I can do a proper cleaning where everything is removed. And I will also clean the faces around it, just to be sure. But the faces around it don't really have anything on them. Like, if you can see, these faces here, they don't have like corrosion on them. So now it's nice and clean. And we shouldn't have a short anymore. We can measure it right here, because the short circuit is very easy to spot, or if you know where it was before. Before it was from the 12 volts to the CPU phase. The incoming 12 volts is this big pad right here that you can see that goes all the way there. And this is the outgoing right here. And it's still shorted. Wow. Okay, I didn't expect that. It is still shorted, so there's even more phases to remove right here. That is pretty bad, because it's on a preheater still. And I will have to take the thermal cam to see which phase it is. But yeah, I currently cannot do that. I would expect that it's probably this one, because this has pushed out solder or something like that similar on its side. Right there. So I would think that this might be the other phase that is broken. But to see it properly, I want that we check under the thermal cam together. So I will take this off of the preheater, let it cool down, and then we will see each other again. The board now had time to cool off. And now we will need to solder 2 wires onto here in order to have a good look at what is happening on this board, where we still have the short circuit left in the V-core phase. So we're going to be positioning our 2 wires accordingly to where we have the short. So we're going to solder 1 wire to the 12 volt input right there, and then to the V-core output right here. So we put leaded solder on both sides so that we can attach now wires to there. So I probably took wires with way too thick of a diameter. Like, that is completely overkill. But make sure to not short it to anything else, just where we want it. So this is now the V-core phase that we connected to. And this one will now be connected to the input to the 12 volts. Okay, I do not like this point where we are trying to put the 12 volts into. Let's use something else. What is very easy to use is just the 12 volts input from the 8 pin for the CPU phases. So we're going to be using the upper one right here. This is 12 volts to solder to it, and it will have a big ground plane, a big power plane, so it will be not easy to solder to, but yeah. So this soldering doesn't have to be great, it just has to be on there. So now we have 2 wires, one going to the CPU phase and one going to the 12 volts. So let's go to the overview. As you can see, the 2 wires now, and let's get the power supply into here. We don't want 14 volts, we want, let's go for 1 volt. So we're going to be connecting the black wire to the CPU phase, and the other one will be connected to the input for the 12 volts. But before we do that, let's get the thermal cam out now. I do not know how much current limit I have, but it's probably a very low current limit. So let's have a look now. We can already see that the area where I was working before is still hot right there. Let's zoom down a little bit with the camera while we can. So we're only going to be looking through the thermal cam here. And let's see now. Let's see how much this will draw. Okay, we are at 700 milliamps. And I think I can already see that it's the one next to it. If we have a good look, it's probably that one. Because that's how the normal one looks. This is how that one looks. And this is only at 700 milliamps at not even of 0.1 volts. So there's not even a watt of power, and this thermal cam can pick it up. Like, you can clearly see that that is hotter than the one next to it. And if we increase the power now a little bit, let's give it a little bit more amps, and now it becomes apparent. Now we can see 2.6 amps, and all of the other phases are cold. All of them completely cold, and only that one actually heating up. So it's only the armmost right next to it that is also faulty. So we will probably have to remove all of what is in that phase as well. And this is barely any power. Like 200.6 amps at 300 millivolt. 300 millivolts is nothing. Like, that is very little power. But yeah, we can clearly see that the armmost is definitely toast. And I want to have a lot of power in there because I want to see if any others are faulty, but it doesn't appear like that. I've had it that you remove one by one until the short goes to like every single other DR MOS, but in this case I think it's really only that one. Let's put the power a little bit higher. So 4 amps at almost a volt. Now we have actually some power going into there. And I cannot see any other heating up. It's only that one. Okay, let's then disconnect the power again. Let's get it onto preheater again and get that DR MOS off. So it had enough time to soak now. Let's get hot air into here again. Let's blast this off. In this case I won't be removing all of the resistors and everything, because I think that will be fine. Just as the DR MOS itself needs to be removed. And yeah, this one had more corrosion under it than I expected it. Let's get this back into focus first. I want to see actually something. Is that pad normally connected here? Yeah, okay, that is one pad normally. Good to know. Because I didn't think that the very first small one that there is actually connected with the big input of the 12 volts. But now it's easy to see, because on the other one it was just all rusted away. But now you can see that the big 12 volt input is also connected right there to that one pin. So let's instantly check now with our multimeter in continuity mode if our short circuit is gone between the input side and the output side. And it is. Now we should have kilo ohms. Very high kilo ohms. And so high. Let's go in a higher range then to see an actual reading. And I cannot get even a reading currently. That is very good then. Because I'm in my 2 mega ohms range and I'm not getting a reading. That is very, very good. So now our short circuit is actually cleared. Not like before where I only took off that one MOSFET that obviously looked broken. But the other one next to it also had enough corrosion on it to kill it. So again, just cleaning it up. So the board is now in a state where it could be powered up already, because now our short is cleared. I can show you that in the overview once more as well. Going into one of the pins of the upper one for the 12 volt CPU and then connecting to the CPU face, you can see almost 2 mega ohms of resistance. So the short is no more that we have that prevented this board from powering on. But the problem is, I lended out my AM5 processor to a good friend of mine that needed an AM5 processor. And I currently cannot test this board. So I will wait a little bit until I get that back from my friend. And when I have that, we can actually finish up this repair. Put back the 3 capacitors that are missing and then start to rebuild these phases as well, in order to put this get this board fully working back for the customer. But it will most likely already work without these 2 phases, but I currently cannot confirm that. One more thing that we can do together is to check the 2 DR MOSes that we've removed in order to check for shorts, because that one that was so corroded might not been shorted, but it probably is. But let's check that before we let some time pass until I get the processor back that I need for this. So here we have both DR MOSes, and let's check now. It should be from this right there to there. Yeah. So this DR MOS is completely blown open. And let's see, let's turn this around. From there to there. Yeah, this DR MOS is fine. So the one that is so heavily corroded right here didn't have a short circuit actually. As we can see, if we probe these 2 points, which is the 12 volt input and the output, it actually isn't shorted, but yeah, it's completely corroded away and broken. As you can see, the pads are gone here. So it might be shorted through a different line, through maybe the 5 volts that gets into here somewhere. Yeah, it doesn't seem like it, but yeah, it's definitely also faulty. But this one is clearly shorted to its output internally from its input. So yeah, the corroded one wasn't actually shorted, but it definitely had to go as well. And the other one was actually shorted from input to its output. So getting back my processor wasn't an option quite that fast from a friend of mine. And yeah, so I went ahead and got another processor. I just bought one that could have been delivered next day. So before we now try to power this on, let's make sure we're going to check everything once more, just to be very sure. So we do not have a short on 12 volts anymore, and we do not have a short from 12 volts to the phase. So we have very high resistance from the 12 volts to the CPU. Let's also check some resistances for the other things like 5 volts, for example, if that has moved up any. And that is kilo ohms. Let's see right there. Yep, 5 volts has now kilo ohms. And we didn't have that before. Like we had 1.6K, I think, fixed on the... Yeah, it went up a little bit, the 5 volts, okay. But still, the 12 volts also not shorted, and the 3.3 volts not being shorted. It has low resistance. What was it, like almost 100 ohms, I think it was. Yeah, 87, that might be fine. Let's check if I can find the PCH resistance right here somewhere. Let's check on a capacitor on the PCH itself. I just want to see for reference what kind of resistance we can expect on there. 117. Okay, that looks very fine on the PCH. Yep, the PCH seems to have high resistance. So that shouldn't be a problem. Let's also check 3.3 volts standby just to be sure. And that also has high resistance. Okay, so I think we can risk putting this processor in. This is a 7500F. So that means this does not have integrated graphics, sadly. And because of that, we will need a CPU in we will need a GPU. But first, I want to see if we even get past the CPU initialization with 2 missing phases on the CPU phase, so on V-core. So what I would expect now is to get beeps for memory. That's what I want to hear, because that would mean that we went past memory initialization and went ahead to that we went past CPU initialization and got to memory initialization. That is what I want to see for this board right now. So let's have a very good look at its passive power consumption first. So passive power consumption, 120 milliamps. That looks very, very good. Well then, let's hit the power button and see. That is very good. DRAM LED 1.2 amps. That is exactly what we wanted to see. That is so good. Okay, let's then... I'm going to be optimistic. I'm going to put a stick of RAM into here. And we are going to get a GPU in here. So let's hit this again and now see. 2.6 amps, 2.8, that looks very good. This is probably RAM training currently. And now let's see some jumping power consumption. RAM training takes a bit, 2.9 amps. Might want to reseat the RAM, because we're stuck on a DRAM LED. Oh no, it's still, yeah, this is very long AM5. That takes a long time to reinitialize. Let's see. Is it going to be stuck on DRAM, or is it actually going to go further at some point? And it cycled again, and there it is. Just takes very long. Oh, it's broken. I didn't notice, sorry. I didn't notice that this was broken. But yeah, there's a picture. I have 5 amps, and now we have an actual picture out of this. This is great to see. So yeah, we had 2 broken phases, or we still have 2 broken phases, but they are not shorted anymore. So this board had a no power because of at least one phase being shorted and the other one was on its way out. So the board doesn't have any more problems. That is good. We now know that, but we cannot leave it like that. We want to rebuild those phases in order for them to work properly. So let's get the CPU out of here once more and protect the socket. So we will have to try to figure out what we need in order to rebuild these phases. I will have to see if I got these DR MOSs anywhere. I think I have a Asus donor board, like a B550, I think maybe even, that has these exact DR MOSs, but I will have to take a good look at that. So let me see if I can find a board view, because we also have all of those passive components around the phase that we want to replace for the one phase. And yeah, let me see if I can find a board view. So it's been some time and I got the arm MOSs now in. And we now have to check for the passive components first, just to be sure to prepare the area properly. So let's see right here that the resistances are fine. This one should be, I think, 0 or 2.2 ohm. 2.2 ohm seems fine. This is, I think, a 1 ohm resistor. Yep, 1 ohm, that looks good. And let's check that other resistor. I think that is a higher one, maybe 10K or something like that. That small one right here. No, this is also a smaller one. Let's see. A 50 ohm resistor. Okay, let's check that this one is also 50 ohms, just to be sure. Yeah, 50 ohms. So all of that is fine. And none of these resistors should be short. The capacitors should be shorted. So all of these have high resistance, which is good. So in this area, all we probably will have to do is to add leaded solder everywhere. Take all of this off just to be sure. But we can do that as soon as we have preheated everything. Then it's easier to do that. And in this area, we have to do some actual work in order to repair this place. And we will also have to get the passive components into here. So before getting the passives into here, I would want to start to work on this area right here. And as far as I know, this pin should be probably... Oh no, this is the connection. Never mind. So the first pin is right here that we have. Then there's another pin going there. Then we have this one going there and that one going there. If we compare that to here, we have this first pin going to here. This pin then going to the capacitor. Then we have this one going there and this one going to the resistor. So the one to the resistor I think is fine. Let's check that for continuity. So from there to there. No, it's not fine. It's actually broken in there. So we will have to also scratch this back and connect it to there. This is obviously broken to here. So we will have to connect these two up together, and there's nothing left here for that part. So we will probably start with insulating the place first. So we're going to insulate all of this here. And yeah, that's probably about... We probably just need to insulate here in between to have this completely insulated. And when that is insulated, we can then start to throw jumper wires from there to there, from there to there, and make a new pad here. So let's do that first and get some solder mask. So we're gently going to put solder mask over here. We can later scrap it back when we need to, just to be sure that we don't short anything out with each other. So now putting the UV light over it, and yeah. So let's see if that is cured enough right here. No, it's not. As you can see, it hasn't cured enough. A little bit has gone hard, but we don't need that much, to be honest. We only needed a little bit. So let's get rid of these pieces and let's insulate that once more. So I think we now got enough insulation. Let's see now if we can work with this and scrape it back. Because we will need this pad right here for the DRMOS. And all of this we keep. And here we want to have it non-insulated, just like that. Because we need to build a pad there. So let's clean that up. So now we have to actually get some places where we can solder to. And where we can then put our wires. So what is the plan here? We are going to do the following. We need this pad to rebuild with whatever we have left here to connect to there. Then with this pad, we can do a connection to this right here. So we can run a wire to there and have it on here. Then this pad is still intact. This one we can just solder it to. And this pad we can also solder a wire from there to here in order to connect it properly again. And yeah, that's about it. So let's see if we can run a small jumper wire from like there to there in order to rebuild a pad here. And when we have that, we're going to also see if we will do one from here to there. But we might want to start with this one first. So let's get one from there to here. Insulated also. And yeah, let's not use the part of the capacitor actually, so that we can still easily put a capacitor in there. So let's Dremel a little bit away here, so that we have a good place to solder to. So, and now we are going to tin these places. So let's tin these. We want solder to bridge over there, and we want solder right here. And then we can also do this and this. And we need to do some dremeling there, that we can actually get that pad. Kinda like that. And now let's get rid once more of the flux, and then we can start to run our jumper wires that are going to be rebuilt for our traces here. So I want to experiment with a new wire that I got. I got 0.02 millimeter wire right there for mechanic. So let's see how well this one works. So let's see right here. This should be a good thickness, because you need to remember the kind of things that we solder here are not supposed to carry much current or anything. The ones that carry a lot of current, they are all fine, thankfully. So let's connect to... We need some more flux in here. So now the wire is attached. Now we want to route it to actually go here. This is the bad thing with my flux. It gets very reflective, and it hardens up like here, as you can see. Let's see now if I can now attach it to there. Kind of like that. But now we have to detach it from the 12-volt line here. Let's clean up so we can actually monitor what we're doing there. So now we can see we have one pad rebuilt with this wire right here. So we have a connection to this right here where it can solder to. We will be insulating that later as soon as I'm done with creating another pad here as well. So the first one's rebuilt. We will also need to build a connection from there to here. So let's do a little bit more of a job there where we can solder this to. Oh, this one is still attached. Okay, never mind. We don't have to rebuild this one. This one is fine. Okay, never mind. We will insulate this later again. So we only have to rebuild this one then, because this now is connected to here. And then we're going to be attaching a wire to here going to there. So our current situation is that we have that with a wire to here with this part, and then we have this one with the wire going over here where we have insulated it. And the big part now will be to insulate it even more, that we don't get shorts between, for example, these two here, and we don't get a short to this 12-volt line here. So for now I want to get a little bit of solder off of that part that we have there, the 12-volt part that is incoming, in order to be able to better insulate the wire, and then we will try to solder on the armors onto there. So getting rid of the solder right there. So just to be sure, we're going to check that we don't have a short circuit between these two. So between this part and that part is no continuity, but to the end of the wire here we have continuity. So we're going to be insulating all of this here and all of that until there, in order to have a part for the armors to solder to. So the area is mostly prepared now. Doesn't look great, but should be fine. We have a wire going from there to there. We have this connection established to there. We have another wire going to this pad right here with the capacitor that we can see right here. This was where the most damage was. Then I got leaded solder on all of the pads so that we can attach that the armors easier. And yeah, the biggest problem is, will it sit flat and connect to these pads properly? But we will be able to check that as soon as we've tried to solder this one on. And what I want to do now, on this one, let's just try to remove all of the old solder here. Mix it with leaded solder and then only get leaded solder onto there, so it's easier to solder to. I've done that on the other one already in preparation. So let me do that here as well. So now both areas are prepared. Both areas have leaded solder on them. And I'm pretty confident this shall work, except this wire. This one will be the interesting one, if I actually can get it attached to this part right here. Because this one has enough pad left over it, so I think that will work. But yeah, this will be interesting if we can actually get to this wire here attached to it. So I went ahead and made a little pad out of that. So I just bent that into something that more resembles a pad here. And yeah, we will see if this now can connect to there. But in order to do that, the board now has to go back onto a preheater. And we will preheat it in order to be able to properly solder these DRMOSs onto here. Let's first see for the DRMOSs that I've got, because I haven't taken a look at them yet. But they should be the right ones. And let's see for their orientation then as well. So there are these ARM BFN0. BFN0 RT. Yeah, that's a different date code, the bottom one, but the upper one is what we actually need. To actually be able to solder to these properly, let's actually pre-tin them. I've seen that these QFN chips are easier to solder if you actually pre-tin at least the outer pins of it. So let's hold this, get some flux onto here. And I want to make sure to get solder onto the on the outer pins of the QFN. So kind of like that. The most important are these small ones here everywhere, that these are soldered, and these the other parts have a little bit of solder everywhere on them. And yeah, I like that, and we will be trying to do that with the next one as well, right here. And this is the next one, also pre-tinned. So let's get these lined up here. So let's put Flux onto here and also Flux here everywhere. So let's line these up, and when they are lined up, then we will put this onto preheater. So we need it this way on here, kind of like that. So we can see we need some exposed there, some exposed there, in order for this to sit. And obviously, because it's pre-soldered everywhere, it won't sit flat. But this is about the way that we will need this on here. So now time has come to put this onto preheater and then actually try to get this on here. So now our board is nice and cooked. I will be now using my hot air station 475 degrees, and I'm going to go very low airspeed, something like 20 out of 120, in order to properly try to put this on here. So it's definitely attached now. Let's go to the next one right here. And this one attached way easier. But I got to be honest, I don't think that this one set properly. I will now let it cool down a little bit on the preheater still. And then we will have a look if our wire is connected where they should be connected. It looks like this one, that one connected, but this one didn't. But we will see for that. When it's a little bit more cooled down, I will clean this off, and then we can have a good look from the side of it. And then we will able to see if the parts are connected or not. So right here we get an actually pretty good look at what happened here. So the board is the chip is sitting proud on the right side here, where the solder mask was, and we can see that some of the parts didn't attach. So this one needs resoldering, this one needs resoldering, this one is actually attached, this one needs resoldering, and that one needs resoldering. But I'm quite happy that with the lineup, so I think I can definitely attach these with just a soldering iron going over there. And this side definitely also has to be resoldered, just to be sure, on the other one. On this side we actually have a good connection. And here there's too little. I want to resolder these then as well. But on this one it's fine. And on this side also, there definitely has to be done more soldering here to attach these better. Probably, no, on this side the lower one is definitely fine, but the upper one needs more. And the upper part seems to be soldered fine. So I will be spending some time resoldering everything here on the sides in order to get a good connection everywhere. And then I will see you again. I don't think there's going to be any much special within what I will be doing here, so I won't show it. But yeah, let me do some of this. So right now, here, we can see that this took me about an hour to do, but now we got everything attached to where it should be. So if we have a good look right here, this wire is attached to here where a capacitor is supposed to sit. And then this one goes to that pad over there. This is a 12 volt pad also connected to there. Then we see this jumper wire going to that pad over there. And then it's this one that still had enough solder for it to solder on. The rest of the chip looks fine now. We now have what is left to do is to put back the passive components around this face. And if we swap over to the other face that we changed, this one was way easier to solder and this one went on pretty easily and well. Because, yeah, there's nothing under it, below it, like on this one where we had to run the wires and get some solder mask onto there. But it should be fine now. So, next order of business is to source components for these passives here and put them on. And now I got all of the components in here. They are partially attached. They now need to be made look nice and properly attached. This is a 1 microfarad 16 volts, 0.1 microfarad 16 volts, 1 ohm resistor, 1 microfarad 16 volts, 2.2 ohm resistor, 49.9 or 50 watt, in this case a 51 ohm resistor that I put there. So, and now what we do, we put a lot of flux onto here on each of these, so that we now can take the hot air station and gently put them all into place. And after some struggling, everything is nice and back into place. So now we got a good connection with all of our components here, and the face is fully rebuilt. Only thing left basically is to clear out these holes here and put the capacitors back onto here. So it's been a couple of days once again, and the last thing now before we can check that it's actually working, once more, 12 volts to ground. We get kilo ohms and rising, which is what we want to see. It's kind of slow rising, to be honest. I thought it would be faster, but it is kilo ohms. And from the 12 volts to the phase, we also got kilo ohms. So it's going to be very interesting now to put the CPU in and see that all of the phases working. I already got my oscilloscope started up now. That we can also check that these phases are running properly. So CPU is in. This is a 7600X. This thing has its own iGPU. So let's see, let's get the 12 volts into here and hope that nothing blows up and everything still works fine. So we see 120 milliamps, so that looks fine. Let's see if this blows up now when we press the power button. And that looks good, nothing blown up so far. Let's check with the oscilloscope some phases. So the board is definitely on. I'm trying currently to get a proper signal read out of this on my oscilloscope. We can already see the post screen, so it's definitely working. I just want to see if we can get a proper read on the phase. So there's the post screen, and now if I take this away, we can now see the oscilloscope. Yeah, it's very dusty and not very great, but I don't have a good capture for this oscilloscope. But if we check the phase now, we can now see a proper phase signal. And if we check the phase next to it that we haven't touched, it looks exactly the same. And the phase next to it as well, the other one that we also worked on, all of the phases have a good signal. That is especially what I wanted to see, that not only is it actually posting, but that those phases that we have reworked are working properly. Because it could have been that those phases just turn off and don't work. But we've now checked that with the oscilloscope that the phases are actually there. So, and let's now see a proper display of the BIOS. Let's see right here. There it is. And now I can go through here. Yeah, and with that, the board is fixed. This took way longer than I wanted to, just because of parts. The big thing is I didn't have a processor for some time to test this. And then also after getting a processor, I actually had to order the RMOSs because I didn't have actually any of them on hand. I still have now 2 more in stock. I've ordered a little bit more. And yeah, we still got the 2 broken ones that we have right here. And yeah, this was a great repair. I got to say, AM4 very rarely has problems with the VRM. Like, actually, blown through the armors and similar things are very rare on AM4. And as you know, I work mostly on AM4 boards. And that is a big part of that is that AM4 has very low power draw. Like, I don't know, I think the highest draw CPU are like 95 watts or something. Or like the advertised TDP is very low. AMD does not draw a lot of power on AM4. And AM5 has stepped that up quite a bit. And for whatever reason, I've had multiple AM5 platforms blow through the ARM MOSes. It seems to be a common issue for them. But they are mostly easy to repair as long as a DR MOS doesn't burn into the board. I have had one board where the DR MOS has burned itself into the board, where it was very difficult to fix that one. But this one was very nice. The corrosion that, well, this one was corrosion based that the damage occurred. But still, way too often I see damage on the phases on AM5. And yeah, but I hope you learned something in this repair, like how I would rebuild a phase, how I do that with connecting the wire when you have to rebuild pads in this case. And yeah, all of my tools, as always, are linked in the video description. If you want to get one of these current meter devices, check out my video description. I have a link there for them. Email me about them. This was Mainboard Medic. Thank you very much for watching, and goodbye.